Okay, so we have f, and we want to show that f equals that. So for a, f at x, so we've got all log base 3, and we're multiplying first of all, because we're adding, and then we're dividing by 4. So then we've got 16 over 2 is 8x over 4, which is 2x. Okay, so B, find the value. This is without calculator. So 0.5. That's log base 3 of 2 times 0.5 is 1. So this is 0. And f at 4.5 is log base 3 of 9. 4.5 times 2, and that's equal to 2. So for C, the function can also be written like that. Write down the values of A and B. So we want to change of base. So we've got natural log 2x over natural log 3. So A is 2, B is 3. Hence, on graph paper, sketch the graph of f for -5 to 5 on both. Okay, I'm not sure what they mean hence from that natural log ax over natural log b, but I'm going to do it from a and b, and this x greater than 0 means we have an asymptote there. So this is our asymptote on the y-axis. Then we have at 1/2, it's 0. And at 4.5, it's 2. And that's that. So we just need to draw it approaching that asymptote. And you could get other points in here if you wanted, but yeah, I don't know how easy that is. So that just keeps going up. Okay, that's that. Write down the equation of the asymptote. Did that. So write down the inverse at 0. Well, that's 0.5. The point A lies on the graph of f at A. X is 4.5. On the diagram, sketch the graph of the inverse, noting clearly the image of point A. So we're just going to flop everything around. So we've got the horizontal asymptote is at y equals 0. We have 0.50, so we're going to have 0.5. And we have 4.52, so we're going to have 2, 4.5. That's A. And this is exponential. The first 4 terms of a geometric sequence are that. Find A, so we're obviously multiplying by 3. So that's going to be 135. Consider a new sequence that. Write down the values of V1, V2, correct to 3 significant figures. So you need your graphing calculator for this. So V1 is 1.61, then V2 is 2.71, V3 is 3.81, and V4 is 4.91. So when you find the differences of each of these, that's going to be 1.1, that's going to be 1.1, and that's going to be 1.1. So that's the difference is 1.1. It's an arithmetic sequence. So if we use log instead in D, we're going to have V1 is 0.699, V2 is 1.18, V3 is 1.65, and V4 is 2.13. do you obtain a similar result? So the differences between these are 4.81, 0.47, and 0.48. So it's because we rounded, but they are very close. If you would have used the whole numbers, it would have been an arithmetic sequence as well. Okay, consider now geometric sequence u sub n with first term a common ratio 3. Write down the first 3 terms of the sequence in terms of a. So for e, we're going to have first term's a, common ratio is 3, so we're going to have 3a, and then 3 squared a. So if we define a new sequence, v sub n, as above by using natural log, we're going to have natural log a, natural log 3a, which is going to be natural log 3 plus natural log a, and then we're going to have natural log 3 squared a, which is natural log 3 squared plus natural log a, which is 2 natural log 3 plus natural log a. And we've done one of these in this packet, so you can see that the difference between each term is a natural log a. A natural log 3. Because between the first term and the second term, we're adding natural log 3. And between the second term and the third term, we're adding another natural log 3. So I'm going to leave G because I think this is a very vague question. And I don't think they'd ask it like that. All right, last one. Solve the following equations. We're going to have x to the 2 is 49. So x has to be 7. I know usually you would say plus or minus 7, but we're in logs. And the base has to be positive. So here we're going to have that's an x, equals 8, so x is 3. 25 to the negative 1/2, that's 1 over square root of 25, so 1 over 5 is x. And d, we have x times x minus 7. I'm going to bring them together, is 3. So we have 2 to the third, 8, is x squared minus 7x. And we have to factor. So we get x is 8 or x is negative 1. And we take the positive 1.